Forget the passive chatbot. An AI agent is less like an intern and more like a relentless engine, one that doesn't just wait for the next prompt, but drives its own logic. What is an agentic loop, and why does it matter now? The concept is famously distilled by AI researcher Karpathy into what's sometimes called the Karpathy loop. Karpathy loop has three phases: plan, act, adjust. In the first phase, planning, the agent decides what it wants to do. In the second phase, action, the agent takes actions using other tools, often other software. In the third phase, the agent assesses what it's done, and then it adjusts the plan. Then the whole loop repeats. The Karpathy loop potentially unlocks this thing called recursive self-improvement. This is the idea of an AI system that builds itself, that changes its own code to make it more efficient and to become more intelligent. So what's happening right now? Number one, agentic loops in business. At JPMorgan Chase, they're using agentic loops in their legal and compliance processes. Instead of having humans manually review documents, now AI agents do it. JPMorgan Chase says this has led to a 20% improvement in the cycle efficiency of their compliance process. Number two, AI agents are already improving themselves. Some AI companies, such as Anthropic, are reporting that 100% of their future models are now being designed and written by AI. AI is suggesting ways that these future models can be made more efficient and more capable. Current systems are evolving rapidly, but they still rely on human evaluations and human-written constraints. That brings us to number three. Self-improvement can carry some big risks. Self-improving systems could optimize themselves in ways that would make them much harder for us to control. A major point of debate in AI safety is this idea of something called a hard takeoff. That's the idea that AI could suddenly start improving itself in a very rapid cycle, and quickly these systems could become more intelligent than people and escape human control. A hard takeoff remains a theoretical or hypothetical risk. Not everyone agrees that it's possible. Today's large language models face considerable constraints that make the idea of a hard takeoff a little more difficult. So should we be worried? Well, today's AI agents do pose some risks. They might choose to accomplish a goal in a way that a user didn't intend. In some safety tests, these AI agents have done things like hacking into software in order to accomplish a goal, even though the user didn't want them to do that. Agentic loops are very powerful, but they're also a bit dangerous. What else do you want to know about agentic loops? Let me know in the comments.